Welcome everyone. Today, we'll explore the exciting new features and major advancements introduced in the latest release of ANSA version 25.1.0. This release brings a host of enhancements across multiple domains, including the modular environment, geometry, meshing, assembly, CFD, isogeometric analysis, crash and safety, results mapping, NVH, durability, design and morphing, optimization, SPH solver, Aeroelasticity, AR and VR, and user productivity. Let's start with the modular environment. The setup of intermodular connectors has been significantly enhanced with new possibilities. The representation can now be set with the aid of connector representation templates that enable the centralized tuning of representation settings. Additionally, new options have been introduced for spring damper connectors, and users can now define local coordinate systems. To improve usability, the distance between the endpoints of applied connectors is now displayed at the bottom of the card. Simulation models can now support different connector representations for the same connector, allowing for appropriate tuning for different load cases. This is achieved by activating a dedicated setting in the modular environment profile, which enables the saving of connector entities within a simulation configuration table. Now, let's move on to the next update. It is now possible to suppress the contents of one or more subsystems and constrain their previously connected interfaces with SPCs. This can be achieved through the new grounding adaptation and simulation models using the convert to ground adapter action. All subsystem modifications, along with the creation of the single point constraints, are applied when the simulation model is built. Next, let's explore an improvement in LS-DYNA substructuring. The LS-DYNA keyword interface linking file can now be defined by directly referencing data available in DM, streamlining the integration process. Moving on to the next update, transformation adaptations are now supported on two levels. This includes adaptations between a subsystem and its subsystem group, as well as between the subsystem group and the simulation model. Regarding geometry, He-Edit sketch function in ANSA now features an advanced algorithm that facilitates intuitive and easy direct editing of parametric sketches. New functionality allows users to create curves along any curvature direction, efficiently capturing edges and feature lines. This reduces the need for extensive scan data processing, thus streamlining the workflow. In the extrude function, faces can now be selected as source entities, significantly simplifying the creation of extruded profiles. The Inspect tool, previously available only for casting parts, is now also accessible for sheet metal parts. It can highlight areas where the sheet metal algorithm was not fully successful. Finally, it's worth mentioning that ANSA now supports importing drawing exchange format or DXF files directly from CAD, thus improving interoperability. Regarding meshing, a new local remesh function has been introduced, enabling the casting tool to run locally with entirely different settings. This allows users to focus on specific areas of the model without the need to run the casting process on the entire part. A new option has been added to the local remesh function, allowing the casting process to operate exclusively in areas with missing mass. When combined with the Inspect tool, this significantly speeds up the process of updating an old FE mesh to align with new, updated geometry. Moreover, a new mesh generation algorithm is now available that aligns the mesh flow on the isoparametric curves of the underlying surface. In addition, new tools have been introduced that allow the user to effortlessly connect parts by consolidating overlapping surfaces, such as flanges. The user can choose the result type, whether by completely deleting one of the flanges, keeping both, or creating a new surface with equivalent thickness. This function significantly speeds up the model preparation process for CFD and electromagnetic applications. A new automatic tool has been introduced to create hexa or pentameshes by projecting the geometry of a part onto a planar face and then extruding it normally to the projected plane. This tool automates the hexa or pentameshing process for parts or assemblies with a common extrusion direction, significantly speeding up the preparation of electronic components. New options have been introduced in the four-sided mesh function, enabling the automatic decomposition of faces into four-sided areas. Additionally, there are now options available to control how the mesh is propagated to neighboring areas, ensuring the creation of a pure quad mesh. This improvement enhances the quality and efficiency of meshing in complex geometries. The Recover Align Constraints feature has been significantly improved. It now delivers more accurate results, ensuring better precision. Additionally, FE parameters recognition has been enhanced. The functionality now includes the option to directly run inspect, allowing users to directly check the result. Finally, the new rubber seal function enables the automatic meshing of weather strips with hexa and penta elements. Moving on to the assembly section. Let me walk you through some updates to the Navigate Connections tool. Previously, ANSA allowed navigation per steady part, but in this release, we've extended this capability to navigation per connection. This provides users with a more granular level of detail by focusing on individual connections. Along with this enhanced navigation, we've introduced new checks and attributes to offer deeper insights. For instance, users can now view the timestamp of the weld inspection, which indicates exactly when the inspection took place. Additionally, we've added information about the user who performed the inspection and the error code triggered during the check. Now, let's discuss the new Navigate engine, a tool designed to enhance part navigation and decision-making efficiency. In this release, we've added the ability to navigate per part, allowing users to focus on individual parts of the model for easier inspection and analysis in isolation. Another key update is the option to approve or reject specific parts of the model. Additionally, we've introduced functionality to display symmetric parts, enabling users to compare symmetry and ensure consistency across the model. Lastly, we've added the ability to generate detailed reports directly within the Navigate engine, summarizing navigation, decisions, and part evaluations. Continuing with the assembly updates, shell seam welds, including wide joint, overlap, edge, laser, and crimp FE representations, are now directly realized on solid connectivity parts. The solids are reconstructed while respecting the width of the heat-affected zones and other relevant settings, ensuring a more accurate representation of the assembly. We've introduced a new clip connection type to the Connection Manager, expanding the ways users can model and define clipping connections within their models. This connection type is especially useful for representing scenarios where clips are used. In addition to the clip connection type, we've also introduced the FE representation rigid mode, offering further flexibility in connection modeling. Moving forward, for RBE3 hexa RBE3 and RBE3 cohesive RBE3 representations, we've introduced the ability to control the RBE3 expansion in cases of curvature refinement. This can now be done through a new field, providing more precise control over the refinement process. Regarding CFD, Fidelity PBS Solver is fully supported. Apart from solver quality criteria that are respected during mesh generation, boundary conditions and solver settings can be set up. Moreover, the user can not only control the solver directly from ANSA and visualize residuals and monitor values, but also they can launch Meta in order to post-process the results. Fidelity Auto Seal is now integrated in ANSA. Automatic gap and holes closure can be now applied so that a fully watertight model can be generated. There are also significant improvements in hexstream volume meshing. These involve notable reduction in memory utilization, along with overall mesh quality improvement and new options for gap resolution. Finally, in Hexablock, there is a new tool for automatic generation of 2D box topology in complex geometries. Furthermore, regarding isogeometric analysis, the instant creation of solid IGA is now possible directly from geometry or from a solid FE mesh, streamlining the process. Additionally, it is now possible to quickly and easily create parametric points on the supported solid IGA entities. A clear and quantitative indication of distortion from the original geometry is now available through fringe plot visualization. Users have control over the fringe bar, allowing for precise monitoring and analysis of the distortion. Furthermore, more realistic models can now be created through the support of initial stresses, effective plastic strain, and history variables for isogeometric shell elements, allowing for more accurate and detailed simulations. In contrast to version 25, this new version has improved creation of shell patches with respect both to the distortion from original geometry as well as to the negative Jacobian. Moving to the crash and safety discipline, we introduced the scaling tool in ANSA. This tool reads all the metadata files from the Piper project, automatically creating the sections and segments for the human body model or HBM. It then scales the HBM up or down by morphing its elements and outputs the scaled model. Furthermore, human body models compatible with the Piper project metadata can now utilize a universal HBM metadata format. This format is applicable to all types and positions of HBMs and includes Piper anatomical entities or landmarks along with the HBM's kinetics. Moving on, the HBM landmark positioning tool utilizes the initial landmarks on the human body model and target landmarks derived from laboratory measurements. It automatically calculates the necessary angles to position the HBM in the target posture by aligning these landmarks. Moving on to some enhancements in the pedestrian tool, the curves of the impact area are now highlighted in a color distinct from the default. To make this visible, ensure that curves color by entity is enabled in the presentation parameters. Additionally, we've improved support for the US NCAP RFC 2025 and FMVSS 208 protocols. Regarding mass calculation, a new action has been added to the Includes/Models context menu. This action generates the deck report's mass information table for the selected includes, allowing the user to inspect all inertia characteristics of the chosen includes. Additionally, an option has been introduced in ANSA defaults to skip elements with undefined properties or those referencing undefined materials during mass and time step calculation. Moving on to the LS-DYNA support, several new keywords have been introduced. These include BLAST keywords, CFD keywords, and the case keyword. New fringe plots are now also available. LS-DYNA load shell entity can be displayed via the L.press drawing style. Element formulation and number of integration points can be displayed via the ilform and int.points options, respectively. Regarding the handling of the includes. After running the find changes function, which has been available in previous versions, the user can now output only the modified includes. It is also possible to compare an include from the list with a reference file. All changes are reported in the Changed Includes window. Users can investigate these changes in more detail by double-clicking on an entity type. If output is selected, only the differences between the two files are exported. For replace, import, and load actions in the context menu, the Input Parameters window pops up, where the user can select the Preview Mode option. As a result, the Merge Models window will appear. We should emphasize the notable improvement in execution time for several functionalities, especially when working with large models in ANSA. First, this improvement is particularly evident when creating a new file. It also enhances the performance of the highlight action, especially for includes or sets that contain a large number of elements. Additionally, the show only action for includes, properties, and context now runs more efficiently. Lastly, switching between two models has become much faster, saving valuable time. It is worth mentioning that the rear impact protocols, EuroNCAP, and CIASI are now supported. Moving on, a great achievement is the significant improvement in the input time of solver files, which is about 60% faster in comparison with previous ANSA versions. Regarding the checks for LS-DYNA Solver, there is up to a 70% reduction for the template run in comparison with the previous versions. A new check was added for multiple element mass part entity definition. The results of the undefined check are now reported as errors and not as warnings anymore. Moreover, undefined materials of undefined parts are no longer reported. Lastly, it is now possible to select a non-rigid part in entities that require a rigid part. In that case, warning messages are displayed both in the entities card and as an ANSA check. Now, let's move on to the results mapping. In the Results Mapper tool, support for Magmasoft results has been added. These results can be formatted for use in CratchFem software. The M2S results file can now be used in the Results Mapper to map results such as porosity, liquid to solidification, and cast length, enhancing the versatility of the mapping process. The Results Mapper now includes support for CGNS or CFD General Notation System files, allowing CFD results to be seamlessly mapped onto FEA models. This enhancement enables the transfer of pressure or temperature loads directly from CFD simulations to structural models. Moving on, the Results Mapper tool now includes a new option to calculate delta pressure for pressure mappings. This addition enables the tool to differentiate between the various pressures in the source model. By different pressures, we refer to scenarios where pressure is applied on both sides of the elements. Regarding NVH, we are introducing a new tool designed to streamline SEA analysis. This assistant simplifies the creation of load cases specifically tailored for SEA analysis. Users can easily generate basic entities for boundary conditions and frequency domains using ANSA cards, which are then transferred into the ANSA database for further processing. Now, let's move on to another major update in SEA analysis. This is our first implementation of an SEA analysis solver, which allows key metrics such as energy, velocity, pressure, modal density, modes and band, modal overlap, and wave number to be computed directly within ANSA, eliminating the need for external solvers. The results are fully integrated within ANSA and can be saved for future reference, as well as reloaded whenever needed. Moving to durability. Let's take a closer look at the updates in the cross-sections tool. In this new version, users can define constraints, as well as set and parameterize the dimensions of the cross-section for greater precision. Additionally, the Direct Edit Sketch feature is now available, enabling easier and more intuitive modifications. Building on the updates in durability, a new tool has been developed to enhance the conversion process for fastener entities. This tool automatically calculates 3D geometric values, such as diameter, length, head diameter, head height, and washer height when converting fastener entities to bolt connection entities through the Feature Manager. Now, moving to the Abacus module, a new visualization mode has been introduced through Check Contacts. This mode allows for reviewing the tied status of secondary nodes using a fringe plot, providing a clear and detailed visualization. This can be done either by using the Abacus data check results or by performing the calculation directly within ANSA. In addition, this new visualization mode is also available through the Inspect function. In this case, the tied status is calculated directly within ANSA, eliminating the need to run the Abacus data check. This further streamlines the review process for users. Moving on, another visualization mode has been introduced. After running the Abacus data check, users can now read the node adjustments due to contacts directly from the solver output check. These node adjustments are labeled as strain-free results within the ODB files. Additionally, the option to selectively apply these adjustments is also supported. Now, in the Connection Manager, a new tool has been introduced to calculate or automatically set the stiffness of a seed bush according to the user's preference. The available options include the Hufschwarman formula, the standard formula for axial stiffness, and a user-defined expression that utilizes known values from the Connection Manager, such as spacing or the length of the connection. Lastly, there is also an option to input a specific value directly, providing complete flexibility for stiffness calculation. In the Beamify structure function, a new option has been added to create RBE2 and RBE3 elements not only at the start and end points of the domain's path, but also at the start and end points of each beam element. This enhancement offers greater control and flexibility when defining the beam structure. This new option is conveniently located in the fourth step of the assistant, under the beams page. Additionally, in the case of RBE3, the weighting factors are automatically calculated by ANSA, further streamlining the process. In the Connect Beams function, several new options for connection types have been introduced. The new Extend End Nodes option provides control over the extension of the end nodes, allowing for precise adjustments. In the case of the rigid connection type, such as RBE2, it is now possible to define degrees of freedom, offering greater customization. Additionally, two new connection type options are available. The first is the spring damper type, like C-Bush, which broadens the range of supported connections. The second is the ability to use a custom user script for defining connection types of any kind, enabling highly specific configurations. Regarding improvements on design and morphing, a new capability allows sub-D to be automatically fitted to their reference geometry or to any user-defined surface. In version 25.1.0, a new feature enhances the member function by enabling the definition of connections. Specifically, spot welds or spot lines can now be added along the new member's flanges by simply setting the target spacing and margin value. A new development in 2D sketching has been introduced, allowing users to design and edit 2D profiles with parameters and constraints. This enhanced functionality is fully supported by all parametric modeling operations, including Member, PM Loft, PM Sweep, and PM Extrude. Users can now effortlessly create a new member by extruding a 2D sketch profile. Furthermore, if the profile is modified, the member can be regenerated to automatically adapt to the updated design. The flatten mesh function enables the unfolding of a 3D mesh into its equivalent 2D flattened representation. This can be achieved either by directly moving the model itself into a flattened configuration or by creating separate copies of the unfolded model. New developments are introduced also in the optimization field. Discrete value optimization is now possible thanks to the integration of algorithms that support mixed integer programming. These include simulated annealing, differential evolution, and NSGA2. This development is particularly useful in scenarios where the optimal design can be derived from a predefined set of values, enabling faster and more precise optimization studies. A new optimization algorithm, called Nelder-Mead, has been introduced. Nelder-Mead is a classical derivative-free optimization algorithm designed for nonlinear programming problems. It uses information about the objective function and is ideal for unconstrained optimization tasks. Since it does not require gradient information, it is particularly effective for optimizing non-smooth objective functions. Now, in the Results tab of the Optimization tool, student Welch charts can be created. These charts allow users to explore the significance of each designed variable by performing a t-test on the available experiments. This new feature complements the post-processing capabilities of ANSA's optimization tool, providing deeper insights into the optimization results. In the field of SPH, introducing coupling SPH with CFD solvers. With this feature, SPH particles can now seamlessly interact with an airfield generated by external CFD solvers. For this demonstration, we've used PBS, Cadence's Fidelity CFD solver. What's great about this integration is that the entire process can be managed directly within ANSA through the PBS interface. This one-way coupling method offers great flexibility and can be applied to a wide range of scenarios, including external aerodynamics, rain simulations, HVAC systems, and many other complex simulations. Now, moving on to another key advancement: bridging SPH and structural analysis. After conducting flow simulations, it's often necessary to calculate the body stresses for structural or fatigue analysis. In these multiphysics conditions, the interaction between different solvers becomes crucial. In this case, we've successfully coupled the SPH solver with Aeroelasticity and NASTRAN by exporting forces from the fluid solver through a straightforward interface. The entire process is efficiently carried out within ANSA, ensuring a seamless workflow for these complex simulations. Moving on to Aeroelasticity. A new ribbon has been introduced in this version, specifically designed to meet the needs of users working with aeroelasticity analyses. This ribbon simplifies the setup by displaying all the necessary keywords at the first level and providing direct access to specialized tools, such as the AeroMesh tool. This enhancement streamlines the workflow, significantly improving the overall user experience when setting up aeroelasticity analyses. Continuing with aeroelasticity, we also have the new AeroSpline tool. This tool features a user-friendly interface that simplifies the creation of spline entities for aerodynamic models. By providing a quick and easy way to define the necessary keywords, it enhances the speed and accuracy of setting up aerodynamic models. Now, moving on to augmented reality and virtual reality capabilities. We've added support for the creation of morph boxes in both AR and VR collaboration. These morph boxes can now be easily created using the controllers or automatically adjusted to the visible parts. After running the marking and positioning process for FMVSS201U in a vehicle, users can now leverage VR and ANSA to thoroughly review the positioning results, evaluate them, and apply any necessary modifications. Let's wrap up with some important improvements in user productivity. The Solve window now provides direct links to the entities related to the reported errors, warnings, and info. Once the user clicks on the link, they can manipulate the reported entities easily through the database browser. Additionally, for the Solver job logs, users now have the ability to load multiple logs for comparison. This enables simultaneous job monitoring, improving the efficiency of tracking and managing multiple Solver jobs. Regarding materials, material encryption is now available for OptiStruct, allowing both partial and full encryption to be performed either in ANSA or during output. In ANSA, the encrypt function in the material list converts the material into a mat encrypt entity. For encryption during output, enable the Encrypt on Output option in the Miscellaneous tab of the Material Entity card. This will keep the material in clear text inside ANSA but create an encrypted material and its related encryption key in the output file. Moving on, a new tool has been added under the Marine tab, called Shell Cluster. This tool scans the shells of the model and divides them into sets based on their coordinates. The grouping is done according to plane, elevation, and section. Shells that do not match any group specifications are assigned to a separate set for further inspection. A new container is available in ANSA. The clipboard can be filled by selecting various types of entities and pressing Send to Clipboard. This does not affect the deck containers. The entities in the clipboard can be exported by selecting the Output option from the context menu. The Function Assistant has now been seamlessly integrated as a tooltip within the Direct Edit function. Additionally, users can now choose between displaying simple or detailed tooltips, offering flexibility in how the available actions are presented. The old Feature tab has been removed, and feature treatments have been elevated to a higher level within the window. Each feature is now neatly organized into dedicated tabs, making them directly visible and easily accessible when active recognition is enabled. The pattern mesh and grids align windows have been redesigned, offering an improved user interface and experience. These updates align with the latest software standards, ensuring a more intuitive workflow. Additional functionality has been introduced, further enhancing productivity in targeted use cases. Last but not least, Z-Standard compression format is now supported. Z-Standard is a modern compression format, similar to the GZ compression which is already supported. This new compression format is available for both ANSA databases and for the input and output of Solver files. This wraps up our overview of the latest updates in ANSA version 25.1.0. Thank you for watching.